So this is MIC 2233 Applied Calc, this is section 2.1. So for number 9 and number 12, they're just asking us, they gave us a domain, and they're asking us to find the range for each one of these functions. And so as you can see for number 12, I have a few ordered pairs. And so the first one is -2 and -11. So in other words, when the value of x is equal to -2, then the value of y is equal to -11. And so the range would be all of the outputs that correspond to the input values. And so -5 corresponds to -1, 1 corresponds to 0, 7 corresponds to 1, and so on for number 12. For number 9, you can see clearly that when x is equal to -2, then y is equal to -1, and so on and so on. So that's the range and the domain. We can also think of it as the input and the output for the particular function. For number 17, they're asking us to find the domain of the function. In other words, are there any values of x that we cannot use? Well, we'll make the function undefined, or will give us a non-real value, if you will. And so for number 17, since it's a polynomial function, the domain of the function is actually all real numbers from -infinity to infinity. In other words, there are no restrictions on the values that I can use for the function f of x is equal to 2x. For number 20, the original they gave us was x plus 3 to the second power. You expand that, you get x squared plus 6x plus 9. And then again, it's a polynomial function, so it's all real numbers. There are no restrictions whatsoever for number 17 and number 20. So just remember that, polynomial function, there are no restrictions. The domain will be all real numbers. Now, for number 21, what happens here is that the radicand, so the 4 minus x squared has to be greater than or equal to 0. And so it can be 0, which is the square root of 0, 0. That's a real number. So f of x has to be a real number. So then we're going to go ahead and solve. 4 minus x squared is greater than or equal to 0. And so what we really can solve then is, in reality, is we can say, okay, so 4 minus x squared is equal to 0, which means that 4 is equal to x squared, which means that the square root plus or minus square root of 4 is equal to the square root of x squared, which will give us plus or minus 2 is equal to x. And so what this is telling us is that the values that will make this equal to 0 would be plus or minus -2. Now I'm going to go ahead and delete this here, and then I'll go back and do number 20, I think it was 22. So what happens with this one is that we have to create intervals. And so I have -infinity to -2, -2 to 2, and then 2 to positive infinity. And so what happens is that we're going to go ahead and choose test values. So I'm going to pick -3, I'm going to pick 0, and I'm going to pick 3. So when I plug in this value into this, so I have 4 minus -3 to the second power, which is 4 minus 9, which is -5. So that right there is a negative value. Since I'm looking for, it has to be greater than or equal to 0, then this interval right here does not satisfy that. Now, if I plug in 0, I get 4 minus 0 to the second power, which is 4. That is greater than or equal to 0, so then this interval should work. And then here again, I'm going to use 3, so it's going to be 4 minus 3 to the second power, which is going to be 4 minus 9, which is going to be -5. So then the only interval, so the domain of this particular function would be -2 to 2 inclusive. So -2 is part of the solution, and so is 2. So that's how number 21 is solved. So whenever you have a quadratic inequality, you're going to have to do intervals. Now, just real quick for number 22, I'm going to put it right over here real quick so you guys can see it here. Number 22, I had f of x is equal to absolute value of 3x minus 6. And this one is actually, again, all real numbers. So there's no value of x that will restrict it. So nothing will be no value will make it undefined, if you will. All right, so number 23, this is equivalent to the square root of x minus 3. And so f of x has to be a real number. So x minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to 3. So this is a linear. The radicand is linear, so we don't have to do intervals. So then if we were to write this in interval notation, it would look like this. If you were to write it in set notation, it would look like this. And so that's the domain for number 23. So let's look at number 25. So this is equivalent to 2 over 1 minus x and then 1 plus x. And so what's going to happen is that we're going to go ahead and plug in values. Actually, we're going to find the values that will make this undefined, if you will, right? So if I do 1 minus x and then 1 plus x is equal to 0, where is this equal to 0, right? And so if I do 1 minus x is equal to 0, 1 plus x is equal to 0, so x is equal to 1, and in this case here, x is equal to negative 1, right, if I move it over to the other side. And so then what happens for this one, and this is similar to one of the questions that you guys had in the homework, if I was doing interval notation, I would have to do it this way, right? So then this is interval notation. Now, if I was doing it in set notation, I would just say all numbers x such that x does not equal plus or minus 1. And that's one way for you to do it either way. All right, so number 29, again, we're going to have to set this. So here we have x squared minus 4x minus 5. This is equal to x minus 5, x plus 1, right? And that's going to be equal to 0. Actually, that's going to be greater than or equal to 0. And so if I find my zeros, I'm going to use 5 and negative 1, right? So when x is equal to 5 and when x is equal to negative 1, this is going to be equal to 0, basically. So then I'm going to have my interval. So I was going to have negative infinity to negative 1. Negative 1 to 5, and then 5 to positive infinity. And so since it needs to be greater than, I'm looking for the positives, right? So this is going to be negative 2, this is going to be 0, and this is going to be 6. So if I plug in negative 2 into this, so it's going to be negative 2 minus 5, negative 2 plus 1. So this is negative 7, this is negative 1. So that's a 7, so that's going to be positive, which is good, right? Let me separate these here real quick. If I'm going to do 0, I'm going to have negative 5 and 1, right? So 0 minus 5 is negative 5, 0 plus 1 is 1, so that's going to be negative 5. Now the next one, if I plug in 6, so it's going to be 6 minus 5, 6 plus 1, 1 times 7, that's 7. So then it looks like the domain for this particular function, if we write it in interval notation, would be negative infinity to negative 1 union 5 to positive infinity. And I'm leaving number 30 extra for you guys. All right, number 41. So for number 41, what they're asking us to do is they're asking us to find the values of the function for what they give us, right? So the first one, they asking us, okay, what is f of 4? So f of 4 is 3 times 4 to the second power minus negative 4 times 4 plus 1, which is going to give us 33 for that particular one. Now, f of negative 1/2 is 3 times negative 1/2 to the second power minus 4 times negative 1/2 plus 1. And then for this particular one, we're going to get 15 over 4. You're welcome to leave it as a improper fraction. The next one is f of a, which will just be 3a squared minus 4a plus 1. And that's it for that one. The next one is, let me get this one back down here. Next one is f of 2 over m. So it's going to be 3 times 2 over n squared times negative 4 minus 4 times 2m plus 1. So then this is going to be 4 over m squared minus 8 over m plus 1, right? That's what we have so far. And so if we kind of cleaned up a little bit, it's going to be 12m squared minus 8m plus 1. And so we can leave it like that, or we can kind of clean it up a little bit, and it will be 12 minus 8m plus m squared over m squared. And so now the last one, any value of x such that f of x is equal to 1. So then we're going to do 3x squared minus 4x plus 1 is equal to 1. So then what's going to happen here is if I subtract the 1 from both sides, I get that, and then I can factor out an x. And so you can clearly see that x is equal to 0. Well, 3x minus 4 is equal to 0, which means that x is equal to 4/3. Now, for number 42, I'm going to do the same thing, right? And so f of 4 is going to be 4 plus 3 and then 4 minus 4. And for this particular one, it's going to be 0, right? So it's going to be basically 7 times 0, which is 0. F of negative 1/2 is just going to give us negative 45 over 4. So you plug in those values and you get negative 45 over 4. For f of a, it's just going to be a plus 3 and then a minus 4. Let me fix that. A looks like a 9. And that's going to be for f of a. Now for f of 2 over m, it's just going to be 2 over m plus 3, and then 2 over m minus 4. And so we can kind of clean this up a little bit, which is going to be 2 plus 3m over m. And then over here, we're going to get 2 minus 4m over m, right? I'm going to make sure that that's equal to what it should be. And so I can clean up even further, which is going to be 2 times 3m times 2 minus 4m over m squared. And so we can probably leave that one like that. The next thing is, where is this function equal to 1? So I'm going to have x plus 3, x minus 4 is equal to 1. So I'm going to FOIL the left side. So I'm going to end up with x squared minus x minus 12, which then is going to be, since it's a quadratic, I have to set it equal to 0. So it's going to be x squared minus x minus 13. And then if I used my quadratic formula, I'm going to have 1 plus a minus, and then this was going to be 1 squared minus 4 times 1 times negative 13, all over 2 times 1. So it's going to be 1 plus a minus square root of 53 over 2. And so the two values that we're going to get is 1 minus the square root of 53 over 2, and then 1 plus the square root of 53 over 2, which this one's going to be approximately negative 3.114, and this is going to be approximately 4.14. So that's how you can rewrite those there. All right, the next one is going to be number 45. And so they define two functions. They define f of x and g of x. And they're asking us to find f of t plus 1. So f of t plus 1 is just going to be 6 times t plus 1 to the second power minus 2. So we'll replace the x with the t plus 1. So that's going to be t squared plus 2t plus 1 minus 2, which is going to be 6t squared plus 12t plus 6 minus 2, which then ends up being 6t squared plus 12t plus 4. And so that's number 45. Number 46 is f of 2 minus r. So then so this is going to be 6 times 2 minus r to the second power minus 2. Sorry, I have to make sure that I wrote that right. So then this is going to be 4 minus 4r plus r squared minus 2. And so this is going to be 24 minus 24r plus 6r squared minus 2. And then when we finish rewriting it, it's going to be 6r squared minus 24r plus 22. So that's number 46. Now for number 51, what they're asking us to do, again, is similar to what we have here. They're asking us to do f of x plus h, f of x plus h minus f of x, and then f of x plus h minus f of x over h. So let's do the first one. Let's do f of x plus h, which is going to be 2 times x plus h plus 1, which is just going to be 2x plus 2h plus 1. All right, so that's the first one. So the second one is minus f of x. So we already know that f of x plus h is 2x plus 2h plus 1. So we're just going to say, okay, so this is going to be minus f of x, which is just 2x plus 1. So when I kind of open everything, I'll get rid of the parentheses. I'm going to have minus 2x minus 1. Those are going to cancel out, and I'm going to be left with 2h. Right? That's what I'm going to have for the second one, which is just f of x plus h minus f of x. Now, so this is A, sorry, this is B. And then for C, what we have now is we're going to say, okay, well, this is going to be f of x plus h minus f of x divided by h, which is 2h over h, which is just 2. And so that's how you do number 51. Okay. Number 52 is going to be very similar, right? So f of x plus h is equal to x plus h to the second power minus 3, which is equal to x squared plus 2xh plus h squared minus 3, right? The next thing is we're going to do f of x plus h minus f of x. So this is going to be x squared plus 2xh plus h squared minus 3 minus x squared minus 3. So it's going to be x squared plus 2xh plus h squared minus 3 minus x squared plus 3. And then when we kind of wrap it all up, we're just going to end up with 2xh plus h squared. Now the last one, right, it's going to be the f of x plus h minus f of x divided by h, which we know is going to be 2xh plus h squared over h, which is just going to be 2x plus h for that one. Now, number 55, I'm going to do the same thing. It might be a little bit more involved than the other two that we did, but it still should be fairly easy. Let me rewrite this here. So this is 2x plus h. All right, so f of x plus h is equal to 1 over x plus h. Now, f of x plus h minus f of x, then it's 1 over x plus h minus 1 over x. Now, when you do this one, what we're going to have to do is we have to have the common denominator. So I'm going to multiply the left side, or the 1 over this one here. I'm going to delete this in a second. And then I'm going to multiply this one by this, right? So then what's going to happen then is that in reality what this is going to be x minus x plus h over x plus h, right? And I can still clean that up a little bit. And so if I were to clean this up a little bit, then it would just be h, or negative h, oops, sorry about that, over x plus h. Now the next one, if I'm going to divide this by h, so it's negative h, right, divided by h over 1, which is just going to be times 1 over h. So this is going to be negative 1 over x squared plus xh, right? And so that's how you do number 55. So number 63, so just be careful with 55. There's a little bit of algebra involved, but it should not be that difficult. So number 63 then, we're going to figure out if it's even, odd, or neither. So what you do is if f of x is equal to negative f of x, then it's even, right? If this is equal to negative f of x, then it's going to be odd, and if it's something else, it's going to be neither. So we're going to replace x with negative x, which is negative 3x, which is equal to negative 1 times f of x, which makes this particular function odd. Now, number 66, we're going to do the same thing, right? So negative f of negative x is negative x to the second power minus 3, which is the same thing as this, which is equal to f of x, and that's an even function. Number 67, same thing, right? F of negative x is equal to 1, negative x plus, and that's going to be exactly the same thing, all right? And so this is going to be even. Now, number 70, right, you're going to see that if I do f of negative x, it's going to be negative x minus 2, which is going to be equal to that right there, which is going to be equal to x plus 2 because, that's just the way you work it out. So if you think about this, this is going to be a neither because it doesn't work that way. All right, let's go to number 73. So for number 73, it is a word problem. And so for this one, what they're asking us to do is to say, okay, so a saw chain, let me make the screen a little bit larger so I can see the text. So it says a chainsaw rental firm charges $20 per day or a fraction of a day to rent a saw, plus a fixed fee of $8 for resharpening the blade. Let S of X represent the cost of renting a saw for X days, and then find the following, right? So the function for this particular thing, for the cost function, and it's S of X, sorry. So S of X is going to be equal to 28X plus 8. So S of 1/2 is the same thing as S of 1 because they're going to charge you for a full day, which is 28 times 1 plus 8, which is $36. So it's going to cost you $36 to rent it for half a day, right? And that's A. B is the same thing. S of 1 is going to be $36, so we already know that, right? That's what they told us. For part C, they're asking us, okay, what is S of 1 1/4? Well, that's the same thing as S of 2, which is 28 times 2 plus 8, which is going to give us $64. So it's going to be $64 for you to rent it for a day and a quarter. For letter D, right, S of 3 1/2 is equal to S of 4, which is going to be equal to 120. So then E, of course, S of 4 is just going to be $120. Now for part G, they're asking us to find S of 4 9/10, which will just be S of 5 because we have to round up here. And that's going to give us $148. And so I don't normally assign H, I, J, or K, so I'm going to stop at 73 there, and that is the end of 2.1. Thank you.